Today we're going to do solving equations, and the first thing is when we had an expression like this, we followed order of operations to solve it. The first thing we did was our grouping symbols. 3 plus 2 was 5. Then we evaluated our exponent. That gave us 25. Then we multiplied, and then we subtracted. We got 93 as our answer. When we're solving equations, we do the exact opposite. We do the opposite of order of operations. PEMDAS, please excuse my dear Aunt Sally, the last thing you would do is subtract. So that's going to be the first thing we do to solve this equation for x. That means get x by itself. You want to move everything that's over here to the other side of the equal sign. So I'm going to do the opposite of the order of operations. The last thing I would do in order of operations is subtract. So that's going to be the first thing I do here. Add 7 to this side of the equal sign, add 7 over here. That gives me 4x plus 2 squared equals 64, because 57 plus 7 is 64. Then the next thing I'm going to undo is dividing. I'm going to divide both sides by 4. Those cross out. 64 divided by 4 is 16. That leaves me with my parentheses and exponents. How do you undo an exponent? You take the square root. Okay? Opposite of squaring is the square root. So when I take the square root of a square, those two things cancel out. And when I take the square root of this side, I get 4. X plus 2 equals 4. My last step needs to be, this is adding. I'm going to do the opposite, subtract. 4 minus 2 is 2. There's my answer. Sometimes I have to do something first before I break down order of operations. In this case, I have two examples of the distributive property going on. So I'm going to go ahead and distribute. 5 times x, 5 times 3, 2 times 1, and 2 times negative x. Still equals 14. Haven't done anything yet. Combine like terms. 5x minus 2x is 3x. 15 plus 2 is 17. Now I'm going to undo order of operations. Please excuse my dear Aunt Sally. The very first thing I should say is there anything here I can get rid of by adding or subtracting? Yes, there's a positive 17. So I'm going to do subtract 17. 14 subtract 17. 3x equals negative 3. Divide both sides by 3. Negative 3 divided by 3 is negative 1. That's my answer. Those two examples have been one variable and a lot of numbers. Here's an example where it's almost all variables and the process doesn't change. I would have the formula for the area of a trapezoid here. Area equals 1/2 height times b1 plus b2. Solve it for b2. Well, the first thing I'm going to get rid of, parentheses are going to be the last thing I touch. So I'm going to get rid of the multiplying. What's the opposite of multiplying by 1/2? It's multiplying by its reciprocal, its multiplicative inverse, 2. So I multiplied both sides by 2. That gave me 2a equals h times b1 plus b2. Well, how do I get rid of times h? I'm going to divide by h. My h's cancel out. And notice what happens over here. I can't divide a by h. I can't simplify that. They're not like terms. So it stays like it is, 2a divided by h. Now I have 2a divided by h equals b1 plus b2. Well, how do I get rid of a positive b1? I subtract a b1 from both sides. But again, they're not like terms. My final answer has not been shrunk to anything. It still has all of the original variables from the first problem. 2a divided by h minus b sub 1 equals b sub 2. If 6x minus 12 equals 18, then what is the value of 6x plus 5? Well, the first step is to solve the first equation for x. The very simple one. I have 6x minus 12. Well, what can I get rid of by adding or subtracting? Negative 12. Add 12 to both sides. Those cancel out. 18 plus 12 is 30. 6 times x equals 30. How do I undo times? By dividing. Divide both sides by 6. 30 divided by 6 is 5. X equals 5, but I'm not done. What is the value of 6x plus 5? We just said x equals 5, so let's put a 5 in there for x. Substitute into the second expression. It's not 6 times x anymore, it's 6 times 5. Put it in parentheses, 6 times 5 plus 5. Order of operations, that's going to be 30. 30 plus 5, final answer is 35.